Hello and welcome to this Red Team Operator video for initial access. Now we will be getting initial access deceptively and evasively. And before we jump into the lab, let me give you a little bit of an overview of what we're going to do today. Firstly, the scenario involves us conducting external recon. So imagine that during an open source intelligence collection, we identify a potential target through an email address associated with the activity of bleeping computer. So this user, we know, accesses this website. And so this gives us a social context. And in doing type squatting, we're able to replicate as similarly as possible that website to be delivered maliciously. So instead of bleeping computer, we come up and register this domain called bleepin computer. Once we have this, we then develop and weaponize our payload. In this portion of the lab and this video, we will be making this payload, which involves process hollowing. I'll explain in a little bit. And it's built in .NET, meaning we'll be writing in C#, or rather it's written for us. And we'll be packing it into an ISO file that includes a decoy XL file, which the user will click, thinking that he's opening up a spreadsheet, as well as a shortcut in order to actually trigger the payload dropper, which is also packed into the same ISO file. Long story short, when the victim visits our cloned site, like I mentioned, bleepin computer, then they will be automatically downloading the ISO file. It's not offered, it's automatically downloaded because we link them to the actual download, not just the website. Upon double clicking, they mount it and the link will open once they click the decoy XL. And our JavaScript loader, yes, it's in JavaScript. I'll show you how we convert our payload to JavaScript, will then execute in the background, triggering for us a beacon on Cobalt Strike. A little bit more on the dropper, although I'll get deep into it. It spawns a suspended edge process. We utilize Microsoft Edge because it's signed. It injects into the entry point. So we take this edge process and then hollow it with our own shellcode, which I'll show you all in the lab demo. And overall, I'll get into the details of this. Now, for today, the learning outcomes include building and customizing your own dropper in C#, converting the dropper DLL to JS, adding a decoy to deceive the target, such as the Excel sheet, using PowerShell to silently trigger and launch the dropper using a shortcut, and then packaging all of this into an ISO file, and a little bit about type squatting. So let's get into the lab. So like I said, we will be using Cobalt in order to receive the callback and get a beacon. I'm going to start up my Cobalt and we'll be building our dropper in Visual Studio. And we'll also be using the terminal. So I'll start up my terminal in Administrator. We will be using Python and WSL. So I'm going to start that up as well. All right, so let's make our project here in Visual Studio in order to build our dropper. Like I said, the dropper is provided in the lab. However, I'll talk a little bit about it so you can get into it and possibly make your own dropper for this lab. Make our new project. So the template that we're going to use is a library with the .NET framework. So class library .NET framework. And we're going to name it MyDropper. And we're going to check off place solution in the same directory. And we're going to leave everything else as is. Create. Okay, so before I get into the dropper and what even is a dropper and how our particular dropper works, I want to make it nice and simple and easy for you and just let you know that we're not doing anything special. On Cobalt, how you regularly generate your payloads, this will generate the shellcode that we're about to use, and I'll show you it in our payloads directory. This right here, this bin file is the shellcode, not this one, the HTTP. This HTTP beacon shellcode is what we're going to use to receive the callback. And because of this, in our Visual Studio, before we build our dropper, we want to go ahead and add it so we can then embed it into the build. So how you do that is you right click on the project in the Solution Explorer, go over to Add, Existing Item, and then you simply navigate to the shellcode that you want to use. So in this case, like I said, we're going to be using the HTTP x64. And once it's in our solution items, we can go ahead and add it to our project, MyDropper. So we just drag it in. And once we do that, we go ahead and click on it, right click, Properties. And once our properties opens up, we need to change the build action from none over to embedded resource. And now this shellcode will be embedded into our build within the dropper, running in memory. So as for the dropper itself, we can go ahead and paste the dropper provided to us from the lab. And I'll go over it briefly. And once we do that, let us go ahead and talk about this dropper. Firstly, the first thing you need to know is that the embedded resource that we're using works like this. We're simply making a variable that is referencing the shellcode being embedded. And it's as simple as that. Now, as for the dropper itself, why is it that we even use a dropper? From all the generated payloads, why don't we just use one of the binaries or, something that we can drag and drop onto our target or something simple? Firstly, number one, this evades static detection. So if the dropper in itself includes evasion, yet the shellcode is signatured, that will prevent you from getting past the initial step of evasion, which is static detection. Secondly, like I mentioned, this shellcode, just like the rest of Beacon's payloads that are generated by default, is heavily signatured. And so having your own customization changes the signatures, or rather the overall signature of the entire exploit. There are still in-memory signatures, which you're responsible to evade. Thirdly, a void library, or load library rather, is too detectable. Whilst dropping a binary onto disk is detected by file scanning, if we use a DLL in memory, we would have to load it, which is detectable. Fourthly, using a shellcode in a loader makes it so the actual payload, which is the shellcode, does not have PE headers. It doesn't have the standard sections, which these things are used to create signatures and are also detectable. So lastly, why we use a dropper is that, as you'll see in the rest of the video, we're going to include layers of deception, such as packing it into an ISO with a link and a decoy. And this is not as possible with a DLL or a binary, alongside many other benefits of using a dropper with a shellcode. So let's talk about the payload. The actual dropper that we're using utilizes process hollowing. This is a shellcode with an embedded beacon, with an embedded shellcode beacon. Firstly, the first thing that it does is it creates a suspended and hidden instance of msedge. We choose msedge as our program for the process being created because it's signed and trusted. When you use a trusted program in your process, this makes it less detectable by EDR. Then it reads the process memory to locate the entry point. And then in that entry point, this is the hollowing part, it injects the malicious shellcode onto that entry point. After that, it completely resumes the process, allowing your shellcode to be ran under that signed Microsoft binary, Microsoft Edge. So now that we have this, let's go ahead and convert it to release mode. And then build it. And in our payloads directory, let's make sure we have the folder for this specific attack, which is going to be called deals. All right. So now that we have that, this build produced our DLL. And what we're going to do to this DLL is we're going to convert it to a JavaScript file. We're going to do that with a tool called Gadget2JScript. And before we do that, let's go ahead and talk about why it is that we're going to need a JavaScript file instead of a DLL. Firstly, we are delivering this payload through a malicious web, mimicking a legitimate one. JavaScript payloads are executed in memory trusted by the low bin called wscript.exe, meaning this is a living off the land binary that allows us to execute our dropper in memory perfectly, in that we're using web delivery as our method of delivering our exploit. This is going to then be triggered using the piped ISO that I mentioned, which includes a shortcut and a decoy. And side note, if we did just use the DLL instead of converting it, or a binary, all of that can just be blocked because that's usually how malicious files are formatted. So when we use Gadget2JScript in order to convert our DLL, we have to make sure that we use the absolute path. This is because when it loads the assembly, it expects the fully qualified path and not a relative one. All of these commands will be placed in the description below. All right, so now this payload, as you can see, is in our deals directory in the payloads. And if you are experimenting with this outside of the lab, make sure to make this deals payload or the payloads directory itself free of defenders detection. So you can add an exclusion in your security, in your defender. So now that we have that, let's go ahead and run it and see if we can test it and get a beacon. Awesome. So as you can see, it works fine. And now let's go ahead and create our decoy, which we'll use alongside this payload. So all we'll do is create an Excel, and we're going to call it deals. And here you can be as creative as possible. So once you're here, you can add in some dummy data if you want to make it realistic. The lab suggests that you add a bunch of products with their discounts and their codes, but overall, this isn't required for the proof of concept, so I'll leave it as it is. Now that we have these two pieces of the payload, we are now going to create a shortcut which will serve as the trigger for our payload, for specifically the JS file, which includes the beacon shellcode. Something needs to trigger this once the user is downloading our ISO payload. And so what's going to do that is in PowerShell, we can use these commands in order to create a new link object. And this is a shortcut that once clicked, it's going to do two things. Firstly, it's going to start our Excel file, which will serve as a decoy. However, whilst the user thinks that it's starting an Excel file, in fact, our JS payload runs silently, thus giving us a callback to our server. As you can see, after running this, I have the shortcut here in the same directory, alongside the beautiful Excel icon, making it super realistic. And so now lastly, let's go ahead and pack all of this into an ISO container, which then the user can receive as one single download, including all of this. And I'll demo myself as the user so that you can see from the user's perspective how they'd be tricked to do this. I also need to mention that when we use an ISO as the container, we are evading the MOTW, the mark of the web. The mark of the web is something on files that can say to the user, this is a random file made by a random person and not by a common legitimate source. However, when the user clicks on this ISO file and it gets mount, opening the folder of our shortcut payload, then there will not be any blocks due to MOTWs. So now let's go ahead and use Python to use pack_my_payload, which will pack it into an ISO. And we'll do that on here, our Linux WSL. Using this command, we have now packed it into an ISO file. Now, once we have this ISO file packed, let's go ahead and host it on our Cobalt. So if we go into site management over here, host file, we'll be able to choose our file. Find the ISO in the deals directory. And we're going to serve it at deals.iso, putting in our fake website as a localhost. And now we have the URL to be provided, to be obfuscated, to be whatever you may want to do in order to deliver to the target. Now, we're not going to be conducting the phishing portion of this. However, I'll show you what happens after that phishing takes action. Now that we have that, let's go ahead and make sure that once the user clicks this, it looks exactly like the site that they trust. So let's go ahead and clone the legitimate site, going into site management, clone site. We can then include the legitimate site, which is Deals Bleeping Computer. The local URL of Deals. And we want to clone this here on this fake site that we have. And we want to choose the delivery that we just set before this that includes the ISO being hosted. You can also log keystrokes on the clone site if you want. And now this is the URL that the user needs to click in order to reach what they think is their trusted site. So, like I said, we're not going to be conducting the phishing. However, let's go ahead and replicate how the user would see this attack happening to them. So, if we move over to the user's workstation, Polly Childs is not having a good day. And now let's go ahead and add in the password. So on the target's workstation, if for whatever reason he was successfully phished, then the target would now reach the URL that we just produced, thinking that it's the legitimate site. And so I'm going to type that out over here. And as you can see, because we specified the download to be this page, the target is now downloading it automatically, all the while reaching this decoy, which looks exactly like the page that we're replicating. However, if the user sees this download or comes across it in the future, then going into his downloads, he'll find it over here and he'll say, well, maybe I want a good deal. And so he'll click on that. You could probably guess that the user will not decide to go further than this point. However, let's assume that he says, okay, let's open. And if he does, he'll find a shortcut. So a victim doesn't usually look at the type and say, hey, that's a shortcut, not the actual file. And so what he'll do at that point is simply click on this deals Excel sheet, looking for some good deals to consider. And I would suspect that that wouldn't matter to the normal user anyways. However, this does seem suspicious. A terminal being open for 5 seconds blank is a suspicious activity. But like I said, I think the majority of users are not interested in security. So at this point, they would see all the dummy data here. However, I didn't put anything. But if we do go back to our server, we'll see that we did get PC Childs right here, the user, PC Childs on his workstation, and we just got a beacon. So at this point, you can live your wildest dreams and start completely enumerating the target's infrastructure. So thank you very much for watching this video. I hope you enjoyed. Please like, subscribe, and comment to let me know what else you would like to see, whether it's through Cobalt or Sliver or any other framework. Thank you very much, and goodbye.